Hello everyone and welcome to our sixth episode on Math Past Year Papers on ZNotes Live. I'm your host Yukan, I'm here with Devandhira, and today we will start with the A-Level Mechanics paper, Variant 2 from the May-June 2020 exam. On to you, Devan.
Okay, so thank you again. And before we start, I'd like to say that we've updated our way of presenting. So instead of doing the past paper itself, the PDF of the past paper, we'll make it into like a presentation, sort of this presentation with a uniform. Right. So let's get started with our AS Mechanics, May June 20. Right. So first question. So let's read. The tram starts from rest and moves with uniform acceleration for 20 seconds. The tram then travels at a constant speed, v meters per second, we don't know what that v is, for 170 seconds before being brought to rest with a uniform deceleration of magnitude twice that of the acceleration. The total distance traveled by the tram is 2.775 kilometers. So for A, sketch the velocity time graph for the motion, stating the total time for which the tram is moving. B, find v, what's the value of v, that constant speed, and find the magnitude of the acceleration. That's for letter C. Right. So let's move on to the next slide. See how we do it. Right. This is for the for the first question, letter A. So it says that it has a uniform acceleration, and after 20 seconds, it reached v. Correct, Yugan?
Mm-hmm.
Right. So that means in 20 seconds, it reached v. It is a uniform acceleration. That means our gradient or our acceleration is just v over 20, right? So this is our gradient, okay? We've reached 20. Now, then it says that it has a constant speed for another 170 seconds. So we have to go from 20 to 190 in that same speed. That means it's a straight line. I forgot to mention that this is a speed time graph, by the way. Speed time graph. We have that until 20 to 190 because it's 170 seconds. Now, at last, it says that it decelerates until it stops twice of the magnitude of its acceleration before. So that means if our acceleration is v over 20, to get our deceleration, we have to multiply by negative because it's going down, decelerating, and you multiply by 2 because the magnitude is twice. So it'll be like a much steeper slope than the other one. But this 200 doesn't come out easily. So what's the reason why I put 200 here?
Oh, you're asking? Because
Yeah.
the initial time was 20 and you're going from 0 to v. Now you're going from v back to 0, but with twice the acceleration. So that means you have to half your speed, half your time. So
Exactly.
then the 20 over 2.
Exactly. So because the deceleration is twice, that means you reach that place twice faster. Instead of going for 20 seconds, you'll go for 10 seconds instead. Right. And this is our what do you call it? Our first answer. We're just asked to sketch anyway. So thank you for the remarks, examiner. Next one is that we should find the value of v. Right. What's the value of v? We can use the information that the distance traveled is 2.775 kilometers. So that means, since this is a velocity time graph or speed time graph, I know it's a velocity time graph actually. That means the area represents the distance covered. Agree? You good? Right. So how do we get the area? Of course, this is just the area of trapezium with our base as 200 and the other side as 170. The height is what we're looking for, which is v. We can just plug in the trapezium formula. This is our height, of course. Our first side, second side, divided by 2. We know we should equate that to 2775. We convert this to meters because everything here is in meters per second. Then we can just solve that. We can multiply by 2 here, then divide by this whole thing down here, and you get 15. Agree? Right. Very simple, right? All right. So we know that v is 15 meters per second. Let's for the next question. Find the magnitude of the acceleration. Sure, why
Mm.
not? The acceleration was given by v over 20, right? Just put that in there. Just 15 over 20, 0.75 meters per second square. That's your answer.
Mm-hmm.
So anything you want to add here, Yugen?
Yeah, actually, go to the part A.
Oh, sure.
Um, no, no, zoom into your
Oh,
answer.
sorry,
I
sorry,
mean,
sorry.
okay. Just to our viewers, those who maybe are starting out doing exam papers or starting out with this topic, when they ask you to sketch a graph, you don't have to do a scale at the bottom. So you can just make like the gradients obvious. So in this case, Devan did his second slope a lot steeper than his first slope and then labeled the important timestamps accurately. So he just has 3 times at the bottom and then V on top. So you don't have to write a scale when you do this whole thing. That's why it's a lot easier when they ask you to sketch something. It doesn't take too long.
Yeah, I agree on that. I really hate if they ask us to draw accurately. You know, my hands just keeps
Yeah.
vibrating. Oh my god. Right. Next question. Forces. Coplanar forces of magnitude 20 Newton, P Newton, 3P Newton, and 4P Newton act at a point in the direction shown in the diagram. The system is in equilibrium. Find P and theta. So here's theta right here. This is P, 3P, 4P, 20 Newton. Sure.
Mm.
We know that this is in equilibrium. That means our horizontal forces are equal and our vertical forces are equal, right?
Mm.
Then let's do that. First, let's do our horizontal forces first. So these are the forces going to the left. Here, I'll show you
Mhm.
here. These are the forces going to the left. So to get this one, of course, you need to take the cosine of 30. Let's say for this force, you need to take the cosine because cosine gives the adjacent. Sorry for the pop-up. And also the same for this one. We'll take the cosine again. We'll take the left, the going to the left force.
Mm.
But there's another force that's going to the right, which is this one. We'll
Mhm.
also have to take the cosine of theta. That's why I equate them here. Agree there?
Mhm.
Then right here we can just simplify stuff up. Cosine of 30 is just root 3 over 2. So we can add them up.
Mhm.
Uh, put that in. 3p plus p is just 4p. So we have 4p times root 3 over 2 and 20 cos theta. I think when I first did this, I tried to make p the subject. Maybe it'll help. I didn't really know that time. So I made p the subject here. Right. We have our first equation. Now let's go for the vertical forces. So right here, I've written the vertical force here, 4p. 4p is right here.
Mhm.
And 3p sine 30. Ah, it's right here. This is 3p sine 30. So basically, you just have to put all the forces that are in one side of the equation, and the other one in the other side. And this is
Mm.
what you'll get here. We can just simplify things more. Sine 30 is just half. So 3 times half is just 3 by 2, which you'll get here. Also for this one, but we don't know what sine theta is. So
Mm.
because I made p the subject in here, I tried to make p the subject in the other equation too, and this is what I got. P is equal to 4 sine theta. Now that we have two kinds of p's, we know they have to be the same. That means we should equate them together. These are both my p's. I equate them together, right? From here we can solve it. We can solve for theta. We can divide both sides by cos theta, and it will give us tangent. And 4 down here, we just simplify it. 10 over 4 is just 5 over 2. Then there's the root 3 down there. You can take the tangent inverse of this, and you get 55.3.
Mm.
And to get p, of course, you just have to put this angle in here or in here. It doesn't matter, and you'll get 3.29. Agree there,
Mhm.
you get
Yep.
anything to add?
Um, Not really. You did this very well. But to the viewers who might not be so familiar with doing these kinds of questions, you can draw on the diagram to help you see which forces are the horizontal and vertical forces.
Hmm. Okay, okay. Right. So next question. A particle of mass 2.5 kilogram is held in equilibrium on a rough plane inclined at 20 degrees to the horizontal by a force of magnitude T newtons. Making an angle of 60 degrees with a line of greatest slope of the plane. See diagram. Yeah, right here, 60 degrees. The coefficient of friction between the particle and the plane is 0.3. Find the greatest and least possible values of t. You're given 8 marks for this. You know how scary that is?
Mm.
8 marks. My god. When I first did this question, oh my god, what do I do here? Right, but it's okay. I managed to do it anyway. So first, I tried to draw a diagram here. It's the same exact diagram as before, but I put more arrows here. So it says that the mass was 2.5 kilogram. That's 25 newtons, right? In terms of forces, it's 25 newton. So that 25 newton acts as our weight here, right?
Mm.
And because our plane is inclined in 20 degrees, we have to make our axis also the same. That means our downward forces is going right here, and this is our sideward forces, and that's our sideward forces. Correct?
Mhm.
Right. So our downward force is just 25 cosine of 20 degrees, because this triangle right here and this one has the same angle. It's similar. They're similar type triangles. So that means they have the same angle. So
Mm.
our downward force would be 25 cosine 20, and our, going to the sideways force is just you take the sine of it because it's the opposite side of the triangle. Right. Also for the other one, for t newton, since this is 60 degrees, I just wrote everything, uh, just in case I need them. You never know if you need them, so you try to find as many informations as possible.
Mhm.
So this is because this is the opposite sine 60. This is the adjacent is cosine 60. Right.
Mm.
So as the question said, we need to find the greatest and least possible values of t. What's t newton? Right. So it says that this is on a rough plane. So that means there has to be a friction, correct?
Mhm.
This is in a rough plane, and they additionally they actually mentioned the coefficient of friction. Right. So for
Mm.
those of you who forgot, the friction force can be represented as this is the coefficient of friction, and R is our normal force. But first, we
Mm.
need to look for what's our R. What's our normal force? So remember, R is the force that reacts oppositely to the surface, right? That's why it's going
Mhm.
upward here. The question is what's the force, right? So we can have the equation right here because there are two forces that are side up. There are upwards and downwards, which is these two
Mhm.
right here. Now the R has to play part in that. So if that means both upward force has to equal the downward force because it's in equilibrium, correct? Right.
Mhm.
So that means if we add the upward forces together, it should equal the downward force. And we
Mm.
can just make R the subject, put this to the other side, and we'll get this one, right? Right. So because we know this is our R, we can just put this here, and we'll get our friction force. But we just don't know what the T is yet.
Mm.
Right. Now this is where the trick comes into play. There are two possibilities. Either the friction is going up or the friction is going downwards to the plane. That's why I have two kinds of plus and minus. There's a plus and minus friction here because if the friction is going up, then it's a plus. If it's going down, it's minus. Do
Mm.
you agree with that?
Yep.
Right. So we have two possibilities here, and we can solve for each of them. You can just transfer this to the other side, and you'll have this equation. Although I made this into one equation because I put the plus minus here. If you're fine with that, right? So we just have to solve for t here. We've got everything i- in one equation in terms of t. We can just solve our t. I didn't solve it here because I have no space. I'm sorry. And when you solve it, you'll get something like this. Or maybe you don't have to get something like this. You'll get the t separately, and this should be your final answer, right? Is there
Mhm.
anything you want to add here? Ethan?
Uh, no, no, there's
No?
nothing to add.
Okay, then. Let's move on to the next question. All right. Small smooth spheres A and B of equal radii and of masses 4 kg and 2 kg respectively lie on a smooth horizontal plane. Initially, B is at rest, and A is moving towards B with a speed of 10 meters per second. That's pretty fast. After the spheres collide, A continues to move in the same direction, but with half the speed of B. Find the speed of B after the collision. Sure, let's do that question first. So, of course, in these kinds of questions where you have mass and speed and they collide, that's telling you to use the momentum, right? Law of conservation of
Mm-hmm.
momentum. So right here, we have our A, which is moving in 10 meters per second, and B is at rest. There should be 2 times 0 here, but because it's 0, then we just ignore it. It has to equal to the sum of the momentums of each ball, correct?
Mm-hmm.
So initial momentum is equal to the final momentum. All right. So A has half the speed of B. Right here, this is the mass of A, and it has half the speed of B, correct? Like from the question here, it says half the speed of B. That's why I put the half here. Right, and so we can just solve this. We can just solve this. So this is just 40. When you simplify this, it'll be 4V. Just divide both sides by 4, and you'll get that V is 10. Correct? But V is
Mm-hmm.
the speed of the ball B. If you want to find the speed for ball A, you need to divide by 2. So it's just 10 divided by 2 and you get 5. Agree there, Egan?
Yep.
All right. So next question. A third small smooth sphere of mass 1 kg and with the same radius as A and B is at rest on the plane. B now collides directly with C. Oh, sorry. I'm sorry. After this collision, B continues to move in the same direction, but with one third the speed of C. Show that there is another collision between A and B. Right. So after B collides with A, B moves and hits C. Now, and it says that B moves in the same direction, but with one third of the speed of C. Sorry. So let's solve that. So this is our ball B here. It moves in 10 meters per second, and of course the mass is 2. And right here, this is for ball B because it says that it moves one third of the speed of C, and this is our C right here. Well, there should be 1, but 1 kg is just 1. 1 times anything is just that thing. So that's why you wrote V. All right. So we can solve this now. 2 times 10 is just 20. Then right here we can simplify 2/3 plus 1 is just 5/3. And we can just cross multiply. 20 times 3/5, that's 12 meters per second, correct?
Mm-hmm.
So the speed of C is 12 meters per second. And how do you get the speed of B? Of course, you just have to divide by 3 because it's one third of the speed of C. So 12 divided by 3 would be 4. Now, how does this show that the ball B will collide with A again? So if you take a look back, A has 5 meters per second, right? The speed of A
Mm-hmm.
is 5 meters per second. And VB has 4 meters per second. Now, the thing is, A is behind B. Because A is faster than B, at some point, it will collide again. Like, it will just catch up because it's faster. And that's how you show that they will collide. You can write it this way. Agree?
Mm-hmm.
Okay. Right. So next question. A and B coalesce during this collision. Find the total loss of kinetic energy in the system due to 3 collisions. That's 5 marks. Well, what's the meaning of coalesce, Yugen?
I don't actually know.
You don't know? Coalesce
No.
means that they stick together.
Okay.
So
Yeah,
A and B,
I know.
when they collide, they just stick together and move, you know, happily ever after.
Okay.
Right. So that means, uh, okay, when they stick, that means we have to consider that the mass are together, right?
Mm-hmm.
So right here, we have the momentum of A well, 4 kg times 5 meter per second. Momentum of B itself when they're separated. Now, since they coalesce or they stick together,
Mm-hmm.
that means our total mass would be 6, 4 plus 2,
Mm.
multiplied by the speed, well, their speed together, V of AB. Right, we can just solve this, of course, divide by 6 both sides, you get 14 by 3 meter per second. But that's not what we're looking for. We're looking for the total loss of kinetic energy, correct?
Mm-hmm.
Now, to get the total loss, of course, you need to find the initial kinetic energy and the final kinetic
Mm.
energy. So the initial, of course, is the very beginning of when all this happened was that AU is moving in 10 meters per second, correct? Right here,
Mm-hmm.
right? And we can just uh, what do you call it? Evaluate the kinetic energy. So for those of you who don't remember the formula, of course, it's right here. It's half mv squared. That's the formula for finding the kinetic energy. So we can just put that in. We can just put half. 4. 4 is because of the mass is 4 kg. V is 10 because it started with moving in 10 meters per second. You just put it in and you get 200 joules. It's energy, so you have to use joules. Correct, Egan?
Mm-hmm.
Right. For the final energy, of course, you would have to add this one right here, the AB together. So it has a mass of 6 and a speed of 14 by 3. So you evaluate that. But also don't forget to add C, the ball C. The ball C is still moving. Don't forget about that.
Mm-hmm.
It's still existing, so you have to calculate that too. So if to add those two energies together, so this guy has a mass of 1. Well, I didn't write it there, and the speed of 12. So from here we can just put this in our calculator, and we'll get our final EK.
Mm.
Right. So to find our total loss in energy, we can just subtract our initial minus final, and this is all we'll get. Though you can technically, when you say you want to find the change of energy, you would do final minus initial, right? But
Mm-hmm.
you'll just get a negative. So you find the loss of energy technically. So it's just the same, right, Egan?
Mm. Yep, yep.
Anything you can add here?
No.
Oh, okay. Right. So next question. A car of mass 1250 kg is moving on a straight road. On a horizontal section of the road, the car has a constant speed of 32 meters per second, and there is a constant force of 750 Newton resisting the motion. Calculate in kilowatts the power developed by the engine of the car. Given that its power is suddenly decreased by 8 kilowatt, find the instantaneous deceleration of the car. Sure, let's do that. Let's do A first. Okay, so we're asked to find the power, right? Kilowatt, the
Yep.
power. That means we can use the formula P is equal to FV, correct?
Mm-hmm.
Okay. So force times velocity. So we have our force and we have our velocity. 750 times 32 is 24,000. Just put that in your calculator and see how it works. And because we want to write in kilowatts, we have to replace these 3 zeros by K. We divide by 1,000 basically, so kilowatts, 24 kilowatts. All right. Second one is that this power is suddenly decreased by 8 kilowatts. So if our power was 24, it's decreased by 8, just 24 minus 8. So we have 16 kilowatts, correct?
Yep.
Right. So the same thing as before, that because there's a sudden change in power, that means the force also changes. The speed is still the same because it hasn't decreased yet. It's still instantaneous. It
Mm-hmm.
hasn't decreased yet. So as before, it's the same formula. P is equal to FV right here. This is our P. This is our F and V. So we need to find our new force. What's that new force right now? So we can just divide 32 with both sides. Don't forget to make this to 16,000 again. So 16,000 divided by 32, that's 500 Newton. So we know that already, right? And then we can use F is equal to ma, Newton's second law. So right here you can see the change of forces, right? It went from 750 to 500,
Mm.
correct? So we have a 250 Newton difference. So
Mm-hmm.
this is the difference right here. And we're trying to look for the acceleration. This is our m. Don't forget that our mass is 1250 kilograms, quite a heavy one.
Mm.
So right here, 750 minus 500, that's just 250, divided by 1250, and you'll get 0.2 meter per second square. Agree
Yep.
there, you can?
Mm-hmm.
Next one. On a section of the road inclined at sine inverse 0.096, the horizontal, the resistance to the motion of the car is 1000 plus 8 V Newton when the speed of the car is V meters per second. The car travels up this section of the road at a constant speed with the engine working at 60 kilowatts. Find this constant speed. Sure. Right, so let's draw a diagram. That would be much easier. So, though I draw a box here, that's actually a car. And it says that there's a resisting force of 1000 plus 8 V Newton. That's why there's the force right here. Agree there?
Mm-hmm.
Right.
Yep.
And don't forget about its mass also. Its mass was 1250. In terms of forces, you just have to multiply by 10. So it's 12,500 Newton. Correct?
Mm-hmm.
No. And there's a downward force also here. You can take the sine theta of it, and that would be our pulling down force, correct?
Yeah. Yeah.
Right. Right. So it says that it's moving in a constant speed. What does that mean, Yugen, when it's moving in a constant speed?
That means the sum of forces should be zero.
Exactly. So the car, of course, has its own driving force, right? That
Mm-hmm.
means that driving force has to equal these two forces that are pulling it back, right?
Yep.
Right. So that means our force, our F right here, has to be equal when these two forces sum. Oh, sorry, pop up. Right. So we have 1000 plus 8V coming from here, and also 12,500 sine theta coming from here. We add them together, and we can simplify this a bit more because they said that sine inverse of this angle right here is sine inverse of 0.096. That means sine theta is 0.096. We can just replace this here. 12,500 times 0.096. Then you simplify it. You don't forget to add the 1,000. You get 2,200 plus 8V. The 8V is still there.
Mm.
Right. Next thing, it says, let me go back here. It says that the engine working at 60 kilowatt or 60,000 watt. That means we can
Mm-hmm.
use our formula again, that P is equal to FV, that our power is 60,000 watt, and our force, which is this one right here, we can put this in, and our V, which we don't know yet, but it's V. So you have the force multiplied by the velocity, correct?
Mm-hmm.
Right. Then we have a quadratic. We can solve for V. So what's the V here? We can just multiply, distribute it, put everything to one side, then pull out your calculator and solve it.
Mm.
So of course you get two answers because it's a quadratic. You get 25 and 300, negative 300. Of course you have to
Mm.
reject that 300 or else you'll be flying back down there. So
Yeah.
this
Yeah.
our velocity is 25 meters per second. Agree here again?
Yep.
Anything you want to add here?
Yeah, yeah. At part B, because they asked for deceleration, it has to be positive, but the mark scheme accepts negative 0.2 as well, because there'll be a lot of people who would negative 0.2. But just to our viewers, when they ask for deceleration and you get a negative answer, put it as positive.
Oh, okay. Exactly. So because this deceleration, you just don't care about negative, correct?
Yeah, yeah.
Okay. Right. So next question. A particle P moves in a straight line. The velocity v meters per second at time t seconds is given by these expressions. So letter A, sketch the velocity time graph for t in between 0 to 13.5, and the acceleration at the instant when t is equal to 6, and the total distance traveled, and at the same interval from 0 to 13.5. Right.
Mm-hmm.
So first job, we'll sketch it first. So I have to sketch this all one by one. Can be annoying, but we have to do it anyway. So you can do this on your own. So we have 2t plus 1 coming going from 1 to 5. So it has a y-intercept of 1 because of the plus 1 here, and a gradient of 2. So of course it goes up, right?
Mm-hmm.
Right. So all that done, we can just, though if you label the y-axis, it's completely fine. I'm not sure if they really require you to do this, but anyway, next one is 36 minus t squared. So right here, it coincidentally meets the line from before. So it starts from here and down. It's actually a curve. This is actually a curve, but my hand is shaky and you see how ugly I draw it. I'm sorry. Yeah. So it goes from 5 to our t should go from 5 to 7, as said from the question here. So it goes from positive down to negative. Okay. Right. So the next one, of course, is the 2t minus 27. So again, it coincidentally touches the line from before here, because if you put 7 in here, in t, you'll get minus 13. Same thing if you put 7 in here, you get negative 13. All right. So you asked to go from 7 to 13.5. And when you put 13.5 here, it's 0. So that means you go from this point to 0. Like that. Okay. So that all okay there, Yugen?
Yep.
All right. Next question is that find the acceleration at the instant when t is equal to 6. All right. So when t is equal to 6, it's following this graph, correct? The curvy graph, the 36 minus t squared graph. And to get the acceleration, we have to differentiate our function here, correct?
Mm-hmm.
Differentiating the velocity gives us an acceleration. So right here, since the graph used is 36 minus t squared, we can differentiate that. We get negative 2t. Putting t is equal to 6, we have negative 2 times 6, that's negative 12. Agree?
Mm-hmm.
All right, so it's just negative 12 meter per second squared. And because it's asking acceleration, don't forget to put the negative here. It's important. Right. Next one, find the total distance traveled by p in the interval of that interval, the whole thing, basically.
Mm-hmm.
Right. Some students would be like, oh, just integrate the whole thing. But no, because you get negative here. If you add positive add negative, that's displacement, right? That'll be displacement, not not distance. Distance doesn't care about how you move back or front, just how much you've been moving. That's distance, right? It's not
Yeah.
effective. So that means we have to integrate from here positively, of course. Then from 5 to 6, integrate normally. Now 6 to 7, you have to multiply it by negative because you know the answer is negative, so you have to multiply by negative to make it positive, correct?
Yeah.
Same thing for the other one. From 7 to 13.5, multiply by negative to make it positive. So now we have this whole bunch integral. I hope you're okay with this. We have from 0 to 5, of course, 5 to 6. And remember, because this part will be negative, I have multiplied by negative here to make it positive. Same thing for the other one. So you can evaluate this on your own. Integral of 2t is just t squared, 1t, and so on. You can evaluate this on your own. Then putting all the limits of integration right here, whatever. And at the end, you can simplify, you'll get this. And your answer should be 84.25 meters. Is it correct, Ethan?
Yep.
Right. Is there
Yeah,
anything else?
that's all correct. For the integration bit, the third and fourth part, for the viewers who are wondering, if you are wondering, instead of multiplying by negative, you can take the modulus of it because your displacement will be negative. But if you take the modulus, you will get the actual distance traveled. So that's something that you can also do. Also, with questions like this, as Devan has pointed out, be really careful when they ask for distance or displacement because, yeah, some of the area is negative, and when you calculate it, you will get a negative area and you might accidentally end up subtracting.
Exactly, exactly. Right. So we're actually done with the paper. This is the last question.
Yeah, okay.
Eh, what do you
Uh,
think of the paper,
do you have
Yugen?
any, it wasn't too bad. I just didn't know what correlates mean, and
Oh,
everything was fine. Any additional notes, David?
not really. I think uh, you just have to be careful with the integration here. You might get because there are so many integrals. Just be careful on
Mm,
evaluating them. Make sure you integrate them correctly and put the integral bounds correctly too.
yeah.
And
Also,
that's it.
yeah, yeah. Again, being careful with the integration. You can't just add the integrals because they have different limits.
Exactly, that's correct. So I'm sorry, but you have to go through this. Right. So I guess that's all for this episode. Thanks, Yugen, for being with me. Your outro, please.
All right. Yeah, and that just about wraps it up for today. I hope all of you enjoyed this session and learned something valuable. And thank you, David, of course, for taking your time to do this session. And good night. We'll see you for the next episode, IG Math Papers. Stay tuned for that this Friday.
Friday, yeah. Right. Thank you, everyone, and we'll see you this Friday.